Welcome back to Makerium, where builders from around the world inspire with every creation. This video tells the story from the very first stage of building a container house. Instead of using a traditional concrete foundation, Julien chose a different approach. A simpler, faster, and far more environmentally friendly solution takes its place: screw pile foundations. A specialized machine screws the steel piles into the ground while measuring the pressure and torque in real time. This data allows the team to verify the load-bearing capacity of each pile. There is no pre-drilling. The piles are driven directly into the soil until they reach stable ground. At 2 meters deep, each pile can support around 5 tons, which is more than enough since a container weighs about 4 tons. The house will be built from 4 12-meter shipping containers placed side by side on a total of 20 piles. From an environmental perspective, screw piles offer several advantages. They require no concrete, use less energy to install, and most importantly, are fully reversible. If the house is ever dismantled, the piles can be unscrewed and the land returned almost to its original state, without permanently damaging the ecosystem. The containers are welded together to form a single, unified structure. Through this process, the basic volume of the house is established, creating a solid and stable framework that will support all subsequent stages of construction. The welded plates are treated with anti-rust paint to ensure long-lasting protection against corrosion. Afterward, the edge joints are carefully sealed with bitumen-based foil tape, providing an extra barrier against water infiltration. The next step involves one of the most challenging phases of the project: cutting the metal walls of the containers. The work is done using angle grinders, carefully removing sections while keeping precision and safety a top priority. Removing the walls compromises the container's structural integrity, risking roof sagging. To prevent this, a 2-part reinforcement is used. In the kitchen, a 15-centimeter section of steel wall is left at the top, and 2 steel pillars support the main roof beam. In the living room, the ceiling is suspended from the exterior roof framework, transferring the weight upward instead of relying on support from below. To prepare the container surfaces, a sandblaster is used to remove old paint, rust, and other unwanted materials from the walls. This method ensures that the metal is thoroughly cleaned down to a bare, smooth surface, providing an ideal base for subsequent treatments and coatings. For the installation of windows, support frames are constructed using OSB panels. The steel walls of the containers are not thick enough to securely hold standard window frames, and there is insufficient material at the edges for direct mounting. The future window openings are first marked using a laser level. This ensures that all cutouts are perfectly aligned and positioned. The markings follow the planned layout exactly, allowing the openings to match the design intentions. Steel strips are then welded to the exterior walls to support the OSB frames. Securely fixed in place, they create solid anchoring points that compensate for the limited thickness of the container walls. If you're appreciating the construction process, please remember to give the video a like and subscribe to the channel. Your support helps us continue sharing amazing new videos. To protect the OSB frames from moisture, a vapor barrier is applied over their surface. This prevents humidity from penetrating the material and ensures long-term durability. Once the windows are screwed, a standard silicone sealant is used to fill the gaps on the inside, while a polyurethane sealant is applied on the exterior for its resistance to UV exposure. The same procedure is used for installing the sliding door, and the space begins to feel less like an industrial container and more like a home. Wooden beams are anchored along the perimeter of the house, forming a continuous framework around the structure. They provide a base for insulation and the necessary support for future exterior finishes. A wooden belt along the perimeter forms a solid base for the roofing framework, providing a level surface for attaching the roof and adding extra rigidity and strength to the entire container assembly. Steel brackets are carefully screwed onto the wooden belt, providing secure anchoring points for the roof beams. The upper structure is now stable, well supported, and ready for the next stages of roof construction. The framework is now fully prepared to carry the weight of the roofing materials while maintaining structural integrity throughout the process. Wooden beams are then inserted into the metal brackets, forming a strong and cohesive roof structure. Installed with a slight slope, the beams create a roof that is intentionally not completely flat, allowing rainwater to drain efficiently and preventing it from accumulating. With the skeletal structure in place, the next stage is insulation. Cellulose wadding is chosen for this task, a material made primarily from recycled newspaper, based on its performance as well as its sustainability. Blocks of compressed paper are torn apart and fed into a grinding machine. The material is then blown through a long hose up to the roof, where the flow is directed to ensure even distribution. Because the container structure is made of metal, it naturally acts as a vapor barrier. By blowing cellulose insulation on top, a highly efficient thermal sandwich is created, improving overall energy performance. OSB boards are carefully laid and fixed over the insulated structure, creating a rigid and continuous surface that provides a solid base for the final roofing materials. The next stage involves the application of EPDM, a synthetic rubber membrane known for its excellent resistance to weathering, UV radiation, ozone, and extreme temperatures. To bond the EPDM membrane to the OSB roof deck, an acrylic adhesive is used. The membrane is folded in half, allowing glue to be applied evenly to both the wooden surface and the rubber before it is laid back into place. Due to the width of the roof, a single sheet is not sufficient. As a result, two EPDM membranes are joined at the roof's peak using a cold vulcanization process, also known as chemical welding. This technique creates a seamless, watertight joint, completing a critical step in protecting the house from the elements. No additional vapor barrier is required, as the steel walls of the container already perform this function effectively. Wood-wool insulation is selected as an ideal compromise between thermal performance, weight, and ease of installation. A multi-layer insulation technique is used to eliminate air gaps. First, the corrugated indentations of the container walls are filled with strips of wood wool, creating a level base layer. Next, wood wool boards are installed horizontally, and finally, an additional layer is added vertically between the structural elements. Once the insulation is in place, a waterproofing underlayment is applied to the exterior walls. This protective layer acts as a barrier against moisture and wind while allowing the structure to breathe. Now the walls are ready for the next stage, providing a secure and durable base for the future cladding. Staying true to the project's sustainable and budget-friendly approach, the raw industrial look of the corrugated steel walls is intentionally kept instead of being covered with drywall. Because the walls are made of steel, a three-coat treatment is required. First, an oil-based anti-rust primer is applied to protect the metal, followed by 2 coats of water-based paint for a clean, finished look. The water system is designed with an arranged sequence of safety. A non-return valve prevents any backflow of wastewater, while pressure reducer regulates household water pressure. Finally, a dual filter system removes sediment, helping to extend the lifespan of the plumbing network. At the heart of the system is the manifold, which distributes water to every appliance in the house. Beneath the container, the wastewater system channels used water efficiently to the collectors. The container floor is uneven due to natural wear, with the center showing a much deeper gap than the edges. To correct this, leveling granules are spread with a broom, ensuring no large piles form. A mason's rule is then used to level the surface, creating a uniform base. Polyurethane insulation panels are carefully placed on the bed of granules using a tongue and groove method. They are lowered straight down rather than slid, protecting the leveled gravel beneath. Fitting together seamlessly, the panels form a continuous insulated layer. The gaps created by the container's corrugated walls are then filled with recycled beads made from graphite and carbon, boosting the floor's thermal resistance. Finally, waterproof adhesive tape is applied to every joint between the panels, enhancing the system's air tightness. At the heart of the electrical system is the main panel, which organizes and controls power distribution throughout the house. The subscriber panel holds the meter and main circuit breaker, while the main electrical panel distributes electricity to all appliances through individual breakers. The communication panel houses the fiber optic line, phone connections, and internet box. All components are enclosed within a duct that provides protection for the entire system. Installing an air-to-air heat pump fits perfectly with an ecological, resilient, and cost-effective approach to living. First, a drywall ceiling is built with vent cutouts to allow the air to be distributed throughout the space. This system draws heat from the outside air to warm the interior, even in freezing conditions, and extracts heat from inside during the summer, transferring it outside to function as an air conditioner. This approach provides a more comfortable and even temperature throughout the house. Each room can be controlled independently via a smartphone. The combination of temperature control, silent operation, and ecological efficiency ensures that the indoor climate is not only comfortable, but also intelligently managed. Wood planks are mounted across the entire exterior for cladding. The first plank is positioned at least 20 centimeters above the ground to prevent moisture from wicking into the wood. Before the cladding is installed, electrical conduits are run between the battens to accommodate future outdoor outlets. The orientation of the cladding is carefully considered. Horizontal lines make the house appear wider, while vertical lines create a sense of height. Here, vertical cladding is chosen, using a cross-battening technique that allows air to circulate behind the wood and prevents moisture buildup. At this stage, the container house begins to reveal its full visual appeal. It no longer reads as a collection of repurposed containers, but as a thoughtfully designed, inviting home, with the wooden cladding adding warmth and character. Julien's decision to install wooden decking for outdoor activities is both practical and sustainable. The process begins with the lawn being cut short, followed by the placement of a geotextile membrane that prevents weed growth. Julien's choice to avoid concrete remains a key part of the project's sustainable approach. Steel piles, much smaller this time, are used as the base for the decking, just as they were at the very beginning of construction. Using a high-torque impact wrench, 16 screws are driven securely into the ground to anchor the main beams. Julien determined that an 80-centimeter screw would provide more than enough stability, but he chose 1-meter screws for added security. The main beams are treated with autoclave protection and anchored to the steel screw plates. The wooden decking boards are then installed with spacers between them to allow for natural thermal expansion and contraction. If you've watched all the way through, we want to sincerely thank you. Your support means the world to everyone involved in this project. You are one of our most dedicated viewers, and we truly appreciate it. We're committed to making our next video even better for you. If you enjoyed this one, please consider hitting the like button and subscribing. It really helps us more than you know. Thank you again for your continued support. To protect the roof edges and prevent rainwater infiltration, they are first covered with an EPDM membrane, creating a flexible, waterproof barrier. Galvanized steel covers are then installed over the edges, providing durable protection against weather, wind, and physical damage. To protect the cladding from UV-induced graying, a saturator oil is applied, deeply penetrating the wood to preserve its natural color and enhance its durability against the elements. The container house now stands as the realized dream of 26-year-old Julien, a vision brought to life over the course of 600 days with the support and dedication of family and friends. Building this container house is more than just a construction project. It's a story of passion, perseverance, and dreaming big. For Julien, every detail shows not just skill and determination, but also hope, creativity, and resilience. Living here is like stepping into the heart of a dream realized. Sunlit mornings bring warmth and promise, while evenings are spent on the open-air terrace with friends, laughter filling the space. Even the simplest routines carry a sense of truly living in a home where dreams come alive, memories are made, and every moment reminds you that life can be fully yours. If this build helped you, stay tuned for more videos coming your way soon. Hit the bell to stay updated, give this video a thumbs up, and drop a comment telling us which part was your favorite.